Right, this is Richmond once again, and then we are continuing from where we ended the other day, and we just want to finish calculus, and then after this tutorial, the next one is going to be application of differentiation, and then we move on to integration. So if you want to understand calculus very well, would I be going to the classroom? Please subscribe to this channel, and then it will be a very good help for you. All right, so we're talking about we've done product rule, and we've also done the quotient rule, and then this tutorial I'm going to teach everything about, you need to know about the chain rule, or talk about differentiating a function on a function, or we call it chain rule. That sometimes they give you some equation, and then no other way, you can't use any other means to get the solution. So we apply what we call the chain rule, and it's going to. But the point is that there's a hidden secret here that I want you to be with me. Watch the video to the end so that you get a key. Because there's something that I can prove with you right now, that if you get to know it, you can just with a second solve every question when it's given as a function. So to get that key, watch the video to the end and you'll find it out. So without wasting my time, please let's flow and let's go. So you have a question like this: y is equal to sine 2x minus 3. Alright, so when a question is given like this one you can't apply your product rule, you can't apply the quotient rule, you can't do the simple differentiation to get this answer. So you have to think here. So we need to convert this expression to a standard form, because sine bracket 2x minus 3 is not in the standard form. So all that we do is that we say that let's convert this on the standard form. So we say that please be serious and look at something I'm saying here. Let u be equal to 2x minus 3. It means that we represent everything here by u. So I can boldly and confidently say that this y is equal to sine bracket 2x minus 3 can be written as y is equal to sine u without a problem, because I said I let u to be equal to this. So if I place u here, mathematically we are correct. So this u here, that's y here. I can find the derivative here. I can say the y over the u, because here is not x. Now it's u here, so the differential with respect to u. So the y over the u is equal to cos u, because if I differentiate sine, I get cost. Okay, so so here we are. So when I find the derivative of sine u, I get cos u. Okay, so this one is good. So look at the question, the chain rule. dy dx equal to dy du. So meaning I have dy du here, correct. So let's find means to get our du over the x. But look at something here. I have u is equal to what? 2y minus 3. So u is equal to 2x minus 3. So here I want to find the derivative here with respect to x. So I say my du dx is equal to what? 2, because if I differentiate 2x, I'll get 2, and I differentiate a constant, give me 0. So du over the x is equal to 2. So I can apply it here and say that my dy over the x is equal to, what is my dy over the u? Okay, we are all here. Dy over the u is cos u. So write your cos u here. Okay. Times, because I am multiplying here. What is my du over the x? My du over the x is here, is 2. So bring the 2 here. Okay. So what can I do? All I can do is I can say I have 2 cos u. But am I correct? Should I leave it like this? No. Because what is u here? I said something that let u is equal to what? 2x minus 3. So I substitute it back here. I have 2 cos, and then my u will be replaced by 2x minus 3. And you are there. Simply, this is the answer for this question. And this is what we call the chain rule. Let's take another question. and we see how we can solve. Y is equal to 3x plus 5 all over 4. Please, as I watch the video to the end, there is a trick that we can just look at the question and know the answer. I guess so. I'll prove that one to you if only you watch the video to the end, because I'm going to do that one right now. So here, all that you want to do is that this thing is not standard. Okay, let's try to make it standard. To make this one standard, we say that let u to be equal to 3x plus 5 here. Okay, and then because I say u is equal to 3x plus 5, I can say that then my y is equal to u raised to the power 4 without any problem. Okay, so what should I do here? I have my dy du, and we know how to differentiate. So the 4 back and multiply u, and the 4u, and then we subtract 1 from the exponent here, and I have 3. Simple. Okay, so let's try this one, and then see u is equal to 3x plus 5 here. And then let's find du over the x here. Du over the x here is equal to what? 3. Because if I differentiate a constant, I get 0. So the u over the x is 3. And what is the chain rule? The chain rule is the y, the x equal to what? The y over the u times the u over the x. So let me continue from very simple here. We have the y over the x here, and we go to dy over the u times the u over the x here. And all that we need to do is that we have our dy over the u, and dy over the u is this one. Okay, so we just need to do substitution. Dy over the u is 4u keep. So 4u raised to power 3 here, and then multiply by our du over the x, and our du over the x is all 3. So you just write out 3 here. So 3 times 4 give us 12. So I have 12 u raised to power 3. And then don't forget that we said something here, let u is equal to 3x plus 5. So we just substitute that one here, and we have what is this? 12, and then the u is 3x plus 5 raised to the power 3 here. Actually, this is how we solve this type of question. Okay, so let's try and do something here. I just promise you that I'll be showing you how we can find the means to solve this one using some small trick, and very simple here. So let me prove it, see how we can use that small trick. That's why I said I have a key here, and I have a trick here that we can use very simple to solve this type of question without even struggling. All that you need to do is that let this 4 fall and multiply the whole of this thing, and it becomes what? 4 multiply the whole of this, so we become 3x here plus 5, and subtract 1 from this place, and we have 3 here. Look at something here. I have 12 here, I have 3x here, I have plus 5 here, so plus 5 here, 3 is correct, okay? And then we now differentiate everything, expression here. Let's differentiate here, so and multiply it to this particular thing. When I differentiate this one, we go 3x will give me 3. When I differentiate 5, it's constant 0. So I have 3 multiplied by this. So 3 multiplied by this one, I get 12. And I write everything here, 3x plus 5 raised to power 3. Within seconds, we are done. So when you see this one, objectives, you can just use some seconds, look at the question and tell the answer. Very simple, without going through the long procedure. So this one is a trick. I have a lot of tricks hidden, and then to get everything, follow to the end of the tutorial. Okay, so let's take another question and see how we can go. Y is equal to tan, and then 4x plus 1, like this. Okay, because of the tan, let's try some. So we let a whole of this one to be equal to a variable, let's say u. We like using u, but you can use any variable, but u is very, very, very good. So let u to be equal to 4x plus 1. And then because I've said that let u is equal to 4x plus 1, it means I can change this one to y is equal to tan u, or tan u, like this. So if I want to find my dy over my du will be equal to what? If I differentiate tan u, I get sec square u. So sec square u. And please, these things that I'll prepare a tutorial on how we can get the basic derivative of all the basic functions. So when you are able to know them and you see them, you can just put them into the expression and go your way. And then that one will be in the tutorial. Please, the point is that to get the best of this thing I'm doing, you just subscribe to my channel, and then I'll be giving you the best tutorial that can change your life. Okay, so let's try to see this place. So the y over the u will give us sec square x here. Alright, so let's try and also find this one. If u is equal to 4x plus 1, so the u over the x will give us just 4, because if I differentiate a constant here, it give me 0. So the u over the x is 4. So because I'm just done, let me just continue here. And so let's try. So we have the u the x equal to 4 here, and we have our dy over the u equal to sec square u here. So all that we need to do is that we have the formula. You need to create a formula here. So your dy over the s equal to what? Your dy over the u times your du over the x, like this. Okay, and then I have my dy over the u to be equal to sec square u. So I just put it here, sec square u. Multiply my du over the x will give me 4 here. So I have 4 here. So what I can do, get 4 sec square u. And I come here, I set something here, let u is equal to 4x plus 1. So u is equal to 4x plus 1. Substitute to this one and have 4 sec square, and then my u will be 4x plus 1, like this. So this is the solution to this particular question. So let's take the last question, and then I know that by then we're done with the last question, you'll be sure to do this question very simple, in a very simple way. So let's try and then see how we can tackle this question. So let's take this last question and see that I know that by this we'll be good to solve every question here. Okay, so we have a question like this one, and then if we actually know the rules of solving this question, it's not going to be a problem, because the answer after all is going to be 5e raised to the power 5x. So if you know the rule, you can just put the rule, put it there, and then get answer straight away. When it's in theory, you have to do some calculation. Okay, so with this one, the same formula here, the y is s equal to the y over du times du over dx. I've been doing this one, but I've not explained why the chain rule is this. Because if I write the y over the u and the u over the x, I mean that du cancel the u, and I get what? dy over the x, dy over the x, same. So that's the reason why we did chain rule. So meaning after everything, there's a cancellation. We don't just write a formula, but after everything, the u cancel the u, and the left with what? Y over dx. So that's the base of the chain rule. So with this one, we say that let u is equal to 5x. Okay, so we are taking away this, and then we replace it with 5x. So if I say that, then I can write y is equal to e raised to the power u. Very simple. Okay, then dy over du is equal to e raised to the power u. When I differentiate e raised to the power u, I'll get e raised to the power u. So that one should be in our mind. That's standard differentiation. When I differentiate this one, I'll get the same thing. So dy du is equal to this. Alright, so what about this one? U is equal to 5x. Very simple, okay? So my du over the x is equal to what? 5. What is the formula saying? The formula is saying that dy over du. And what's my dy over the u? This is my dy over the u. So I write u multiplying my du over the x, which is 5. Not 5 here. So 5 multiply this one, have 5 e and u here. What is my u? I said something here. Let u equal 5x. So I'll replace this one back and get 5e and then 5x. I said this one earlier on that the answer is 5e raised to the power 5x. Because the point is that if this one is your function, you have to differentiate the exponent and you multiply it by the base here. So when I differentiate the exponent, I'll get 5. You multiply by this one, I get 5e raised to the power 5x. So if you find this question, the objectives, don't try to do a long process like this one. Differentiate this one, multiply by this one, and then just replace the whole of this expression again back, and then you get your answer correct. So if you like what I'm doing, just subscribe to my channel for more videos like this one. Thank you.